Hey folks, welcome to this new Cancha tutorial. I'm going to talk about metallurgical data in Cancha using Cancha 2.4. And so first thing to understand, what's a metallurgical sample? As far as Cancha is concerned, a sample is a single continuous interval of drill core. It could include many geological samples. So geologists usually talk about a sample as individual assay intervals. Whereas in metallurgy, we're talking about a sample which could include several of those. But the important thing is that it's continuous. It has to be, a continuous run of core from a single drill hole. Whereas a composite, first of all, you would import the samples, and then a composite can be a mixture of samples, two or more samples. Now, the geologists would call this a composite, a single, metallurgical sample. They would call that a composite. But in Cancha's very strict terminology, that would be a sample, and a composite would be a mixture of samples. If it's not already imported as a metallurgical sample, you're not going to be able to use it as a composite component in Cancha. So first samples, then composites. Phases. This is really important. It's obligatory in Cancha that every sample has to come from a phase. Phases are super useful for grouping data and analyzing data and filtering and stuff like that. Basically, it's any way that you want to group them, but normally it would be from a single laboratory or a single sampling program. We would, in Transmin, we just use phases 1, 2, 3. Sometimes we might use 3A for comminution, 3B for flotation, for example, so you can do that. It's just a string. You can call it anything you want. If we're doing an operating mine, where we're doing geometallurgy on an operating mine, we would say, GM 2018, GM 2019, with just one geomet program per year. Just try to avoid using PEA or PFS as a phase, because as we all know, there's always at least 5 PFSs on any project that gets built. And, each of those PFSs might have samples to different laboratories for environmental, comminution, materials handling, extraction, concentrate work, solid liquid separation. So it's better to keep a little bit more granularity than just PFS samples, okay? Metallurgical data is broken down into origin, characteristics, parameters, and results. So origin basically says where the samples are from. Characteristics say how the geologists see the sample. What does it represent geologically? How can it be modeled geologically? Parameters are something that the metallurgists decide in the laboratory. For example, grind size, reagent addition, pH or something like that would be things about parameters. They've got nothing to do with the geology of the sample, but they could still be useful as predictors for a metallurgical result. And results, finally, are the things that you want to predict. Now, just note that Cancha doesn't use results as predictors for other results. So if you're running targets, results will be excluded, but information about the origin, characteristics, and parameters will be included. So where you're declaring your origin, you always have to have a phase. You always have to have a sample ID. You're going to hear this time and time and again. Every data type, you always have to have the phase and sample ID. You can have, you can only have one sample with the same name in each phase, but obviously you can have samples from different phases with the same name. Quite common to have Met01 as a sample name. You could have that same name in 2 different phases, and there'd be different samples. Okay, so you got phase and sample ID. Next thing would be drill hole from and to. So that's basically saying, where the sample's origin was. Incidentally, the drill hole should always be a drill hole from the existing drilling data that you've imported. It should have a collar and a survey and whatnot, so we can locate it in 3D. To do some of the things like graphs and whatnot, you can get away without having drill hole information for metallurgical data. But if you want to take advantage of looking at things in 3D or having geological features transposed onto, projected onto metallurgical samples and stuff like that, then you will need to have it from an existing drill hole. And, take care that the drill hole has to be named the same way. It has to be letter perfect. It has to be, you can't miss a dash or miss a letter or something like that. So those ones in blue are the ones that you have to have. Afterwards, you can have other things, whatever you want to do. You can have extraction dates or type of sample, what laboratory they went to, anything you want, really doesn't matter. We might often put a valid sample Boolean in there. So we might say, for example, is this a valid sample? And so instead of having to adjust the data in Cancha, what we can do is just re-import the origin table. And if there's samples we want to exclude, we just put a 0 and put 1s for valid samples. And then we can have a filter in Cancha that only considers samples that have a 1 in the valid sample column. That way you've got all the data in Cancha, but the target or whatever only considers the valid samples. Anyway, that's an aside. Basically, after these 5 things, you can have anything else you want in the origin table. And you can have multiple origin tables for the samples. So each phase, for example, might have its own origin table. Nothing wrong with that. Characteristics. So, like I say, any way that a geologist would describe it. So always phase, sample ID. Those are the only 2 obligatory ones, right? You no longer have to talk about from and to. You don't have to say drill hole. You don't have to say XYZ or northern eastern URL. That's all going to be calculated automatically. Don't worry about that. In this table, only put something like, for example, head assays, mineralogy, lithology, all those sort of things that might come as descriptors. You can put them here. If you've got a lithology table in your drilling, you don't have to, it gets projected automatically. So you don't have to have a metallurgical lithology table. It'll already be projected automatically in Cancha. But maybe the geologist might have given you their own summary, so you might want to import that to be able to compare. Use separate tables for each. So have head assays in a table called head assays. Have mineralogy in a table called mineralogy. Makes it a lot easier to get around and find things. Parameters. So exactly the same, just metallurgical decisions. Phase, sample ID are obligatory. After that, you can have things about reagent addition, grind size, pH. Now, oftentimes, if you're just looking at variability data, all the tests might have been done under the same conditions. So, might not be necessary to have a metallurgical parameter table. Quite often might miss it off. But, if you're doing a whole bunch of bond work indices over different phases might have used a different closing screen, or it might have had a different sample prep and different FAD, for example. So you might want to bring those in as parameters. Okay, so next would be results. So this is the stuff we're trying to predict. Typical ones might be things like recovery or reagent consumption, whatnot. Again, they have to have phase, sample ID. Those 2 columns are obligatory. And the results, as I mentioned, are not going to be useful as predictors. So, you don't want to use, for example, BWI to predict, a SAG index, for example. It's not going to be useful. You don't want to have, the 6-minute nickel flotation recovery to predict the 8-minute nickel flotation recovery. They'll have excellent correlation, but it's not going to be useful for for the geologist to populate, they're not going to be able to populate that in the block model. Okay, so there's the results. Now, when they're imported, you always have to have the phase and the sample ID, and then you've got to have, the data. The top line should always have the field names. The field names can be any characters you want, but can only be 1 line. And this can either be in Excel or it can be a CSV format. I recommend that you bring it in as a single Excel workbook. So let's just go ahead and have a look here at the Bonnie dataset. So here we've got the Bonnie dataset. And this spreadsheet here, the first tab, we've got the met origin, phase, sample ID, drill hole from to. So these are the ones that are obligatory. Got those all mapped out. And then we can have optional columns here as well. So there's the origins in one table, head assays in another. So you'll notice that there's no gaps in the columns, no gaps in the rows, just one big table Okay, SG, whole rock assay, parameters. So here we do have the F80 and P80 for the bond work index test, for example, for phase 2. The results of cyanidation here. So we've got, the cyanide consumption and the gold recoveries for each of these samples. Comminution results. And finally, we've got composites. Now, the way composites work is you've got to have the full list of samples in the first place. You don't have to have a full list, but you have to have a list of samples in the first place. And then the names of the composites are the new fields, the new features. So you've got the phase, sample ID, then you've got the composite 1, composite 2, composite 3. And these are the relative compositions for this composite 1. So it's taking two, for example, 2 kilos from sample 2, 2 kilos from sample 4, 2 kilos from sample 6, and 2 kilos from sample 8. There's another video on composites in Cancha, so go ahead and watch that if you get confused. But basically, this is the format for composites. All right. So now let's just get into Cancha and we'll start importing this data. I just started up this new this file, this empty file, and going to have go to the data, go to add to table, and here we've got the where are we? Met database, and here in the Met database we've got the it's gone ahead and it's opened up this Excel file and it's got all these different tabs that we just saw, and they're all there. Now the composites are being brought in. It's guessed as characteristics. It should be a composite. Head assays is characteristics. Origin, so it gets that correctly. SG, characteristics. Whole rock assay, characteristics. Parameter, there's a parameters table, that's correct. Results, cyanidation, guess that correctly. Results, comminution, that's correctly. Okay, so those are the way that you assign them. You always got to make sure that the origin's an origin and results are results. Most of the others, I guess, by default is characteristics. So here we've got the composites, and it's saying that the sample ID is sample ID and phase is phase. So because we named them like that, it's super easy. Then the rest are just the composites. No problem. Next. You can put in a manual phase if you want, and you could sort of manually say that everything's a single phase. So because sometimes you might be importing some data and you forgot to put the phase column. I really don't like this. Don't use this if you can. Fix your data before you bring it into Cancha. Get those names phases in properly. As we can see here, here's all the head assays, and we've got all numerical, all looking good. So next, Met origin, sample ID, phase, drill hole from and to was all guessed correctly. And then we got these other couple, program and leach comp information that's separate. All good. Just go next. Now we've got SG, so it's just pretty simple. Just sample ID and phase. SG, numerical, looking good. Whole rock assay, bunch of numerical stuff here. Sample ID, phase. Use it. You have to be disciplined. You have to be checking it every time, because if it gets it wrong, you're not going to be able to work with your data. It's super frustrating. Sample ID, phase, numerical stuff here in parameters, looking good. What's left? Results cyanidation, good. Results comminution, these are all numerical, that's fine. And so what it does is it reconsolidates everything, and it projects drilling on there and stuff like that. Now if I come here to 3D, you'll notice that in the metallurgical samples I've got red drill holes here because I haven't imported the drill collars. Okay, so we can't see anything in 3D. All we've got is the origin, characteristics, test parameters, and results. We've got all that in the composites. We've got it here in the. So if we wanted to do, for example, for a graph, we could put the SG versus the gold recovery, for example, and it didn't give us a graph. Let's do something else. Let's comminution, appraisal index. Okay, so it gives us a graph. So you can draw a graph with it, and we could even run targets. Like say I wanted to run the target for a gold recovery. I've got all these possible features, but I don't have the XYZ, and I don't have any geological features, but I can run that. And it'll give me, some possible models for domains and for regression. If I import the collars and bring those in as drill collars, and then just have won't bring in the survey. So we've got the eastern, northern, and RL, the drill hole ID, length, azimuth, and dip. And we use all that and don't use surveys, then it will hopefully show me now the samples. So if I bring up DWI, now I can see them in 3D. Okay, so now you can see that all the met samples have gone black. The ones that are grey don't have drop work indexes. This is why they're grey. So the feature that we've loaded up into 3D is grey here, just because there's no data for it. But if we go, for example, to cyanide consumption, then then there's a different set of samples, and so that's why some of them are grey. We can do things like put on the labels on the 3D, do that. We can also change them to a circle and make them big, so it's kind of easier to see from every angle if they're a sphere instead of a cylinder. But if we go the cylinder, then it's more accurate of the intercepts that have been used. Other things to know is that here we can click on this and see the composites. So here I can click on BC01 and it'll show me which one's from that composite, or BC002, that's that composite. And you can see it's grayed out the ones that were not part of the composite. We're going to be moving composites from here and put a separate tab here on the side, just so to avoid this unfortunate interface here. Something else to know about is drill holes. If you touch this button here, this is going to only show you the drill holes that have met samples in them. Now, right now, you can see all the holes have got samples in them. They're all blue, so it didn't make a change. But, if you've got a few hundred drill holes in a typical mine, and then only a few of them have met samples, then only the ones that met samples will be blue here in the list. And if we hit on this one here, it'll reduce this list to only show the ones that have got met samples in them. Okay, and as I said in the logs, we're representing the met samples here by the thing in the background here. You'll also notice here in the origin table, there is now an eastern, northern, and RL that's been calculated, and we can put that on, and it'll show us the value of the. There's now something you can use this value, the eastern, northern, and RL. It'll be there in the targets if you run a target. So you didn't have to calculate the location 3D, it's calculated automatically by Cancha. I think that's it for the metadata. Fantastic.